let's come to covalent bonds. Covalent bonds are formed when two nonmetal atoms share valence electrons. Their electrons in their outer shell are known as valence electrons to gain stability and have an electronic configuration similar to that of gases, inert gases such as helium. Describe the forces between the molecules of covalent bonds. So covalent bonds are strong. Why? Because a lot of energy is required to break them. Then covalent bonds often form molecules with low melting and boiling points, for example, hydrogen and water. Why do they have low melting and boiling points when the covalent bonds are very strong? Shouldn't their melting and boiling points should be higher than that of ionic compounds? Even though covalent bonds are stronger than ionic bonds have higher melting and boiling points than covalent bonds. Why is that? That is because there are very strong covalent bonds inside the molecules, among the molecules, between the elements. For example, when you have NH3 ammonia here, so all the NH bonds are very strong covalent bonds, but each NH3 molecule is attracted to another molecule through a very weak force of attraction. When you melt a covalent substance or you try to boil a covalent substance, then these forces of attraction are overcome, which are very weak, hence the melting and boiling points of covalent compounds are very low. Why are covalent bonds difficult to break? So the covalent compounds can be easily melted or boiled, but the bonds are never separated when you melt or boil a covalent compound. So why are these bonds very difficult to break? Because the nuclei, they are strongly attracted to the shared pair of valence electrons, hence the bonds formed are very strong and you require a high amount of energy or very high temperatures to overcome these bonds. How do hydrogen and chlorine form hydrogen chloride? So let's have an example. Hydrogen has one valence electron, one electron in its outer shell, whereas chlorine has 7 electrons in its outer shell. Hydrogen needs 1 electron to become stable and chlorine also needs 1 electron to become stable, so that both of them can attain the electronic configuration similar to that of gases such as helium, inert gases such as helium. So hydrogen can share its electron with chlorine. So chlorine will have a full outer shell that will now contain 8 electrons, and chlorine can share one of its electron with hydrogen, so that hydrogen also gets 2 electrons and hydrogen is also stable. So now when you have shared pairs of electrons, you have one shared pair of electrons, you have a bond formed, a stable bond formed, hydrogen chloride. Now, how do we know which elements are going to form multiple covalent bonds? Right now, in the example of hydrogen chloride, only one pair of electron was shared, so only one bond was formed. How do we know which are going to form multiple? So you can have a look at this table. It's actually relative to the group. So group 4 elements, you're going to subtract the group from 8. 4, 5, 6 and 7 groups contain nonmetals, and nonmetals form covalent bonds. Now for each group, you're going to subtract the group number from 8 and you're going to get the number of bonds to be formed. So carbon will always form 4 bonds, and we're going to study later on in organic chemistry as well that carbon will always form 4 bonds. Nitrogen on the other hand forms 3 bonds. So 2 nitrogen atoms together are going to form 3 bonds so that they can become stable, and we're going to study nitrogen as well. Oxygen forms 2 bonds and chlorine forms 1 bond. Because chlorine just needs 1 electron, oxygen needs 2 electrons, nitrogen needs 3 electrons, and carbon needs 4 electrons to become stable. So let's have a look at the dot and cross model of nitrogen. It shares 3 pairs of electrons. Why? Both the nitrogen atoms have 5 valence electrons and they need 3 more to become stable. So each of them are going to share 3 of their electrons, and now if you count the number of electrons in each shell, you're going to get 8 electrons. And in doing so, you have 3 shared pairs of electrons. So you're going to draw 3 lines between 2 ends, and that will represent that nitrogen forms 3 covalent bonds. Now, what are the properties of these covalent bonds? And we'll also again discuss that why do these properties exist. So they have low melting and boiling points. Why? We discussed that a relatively small amount of energy is required to overcome the weak attractions between the molecules. So these compounds melt and boil at much lower temperatures than metallic and ionic compounds do. In fact, many compounds in this class are liquids or gases at room temperature. They have soft or brittle solid forms. The weak intermolecular forces make the solid form of covalent molecular compounds easy to distort or break. They're insoluble in water. However, they're insoluble in organic compounds, organic solvents, for example, ethanol. Why? Because when covalent compounds dissolve in water, they break apart into molecules but not individual atoms. When you have NH3, the different molecules that were held together by weak forces of attraction, they're going to separate, but the NH bonds are not going to break apart. Individual atoms are not going to be formed. Hence, they're going to remain insoluble in water. The covalent compounds won't dissolve in water, and instead they're going to make a separate layer on water surface. They have poor electrical and thermal conductivity. They are insulators of electricity and heat. Why? Because where ionic compounds conduct electricity when melted, metallic solids as well, covalent compounds do not. Examples of covalent bonds are simple molecular covalent bonds and giant covalent structures. So let's first have a look at the simple molecules, and then we'll move to the giant molecular structures, or the macromolecules. What is a simple molecule? It has very few atoms held together by covalent bonds. For example, carbon dioxide. It's a simple covalent molecule. And what are the properties of these simple molecules? They're similar to those of covalent bonds that we just discussed. They have low melting and boiling points. They are not good conductors. They are volatile. What does volatility mean? It means that they can change their state very quickly from liquid to gas. Because they have weak intermolecular forces, they can take heat from their surroundings and they can change their state. They are usually gases or liquids because of the weak intermolecular forces between molecules. They are mostly insoluble due to no ions for water to pull, and they are poor conductors as they aren't charges of free moving ions. Now let's have a look at the idea we've been discussing for quite a long time. Why do they have low melting and boiling points? Because if you have a look at this diagram, this shows water. Now the solid lines are showing strong covalent bonds, strong OH bonds, whereas the dotted lines are showing weak intermolecular forces between each H2O molecule. These forces can be easily overcome when you try to melt or boil a covalent compound or you put it in water, but these strong bonds are never broken. So these molecules are separated. And to break these strong bonds between the molecules, that requires very high energy and very high temperatures. So now let's come to molecules, giant molecular structures. What are allotropes? Allotropes are elements that are formed in different forms. For example, carbon can be found as graphite and diamond. So these are allotropes of carbon. What are giant covalent structures? They are also allotropes. They contain many atoms, each joined to adjacent atoms by covalent bonds. Whenever they ask you about macromolecules or giant structures in your exam, you have to mention the term covalent. That's very important. And these covalent structures are arranged into lattices, very neat, orderly structures that are very strong because you have a lot of bonds involved. So what are these three lattice structures representing? The one on the left shows graphite, the one in the center shows diamond, and the one on the very right shows silica or silicon dioxide, or in common terms, sand. So on the right you have silicon dioxide, the gray molecules represent silicon and the red molecules represent oxygen. In the center you have diamond, which is an allotrope of carbon, and each black molecule is representing carbon. And graphite is also another form of carbon, so these black molecules once again represent carbon. We're going to discuss each of them individually. What are the properties of all of these giant molecular structures? They have high melting points because of the many bonds involved, and you need very high energy to break them. For example, graphite has a melting point of higher than 3600 degrees Celsius. They have variable electrical conductivity. Some conduct and some do not. Diamond does not conduct. Graphite conducts electricity because it has free electrons, and silicon is a semiconductor, but we sometimes also consider it to be a non-conductor. What is another name for intermolecular forces? Van der Waals forces. That term can also be used instead of intermolecular forces. Now let's have a look at graphite. If you can see, each carbon molecule, each carbon atom is bonded to 3 other carbon atoms. If you have a look and you quickly count the bonds, each carbon atom is bonded to 3 other carbon atoms, and this is a 2D structure where you have different layers. Over here I can see 3 hexagonal layers in this diagram, and these layers can slide from each other. Why? Because once again, the very same concept, these carbon atoms are held strongly together with covalent bonds, but each layer just has weak van der Waals forces or weak intermolecular forces between them, so they can easily slide over each other. And due to the sliding, graphite has a soft and slippery texture, and that's why graphite can be used as a dry lubricant. What are the properties of graphite? So we discussed that each one is bonded to 3 carbon atoms. However, 1 electron is always left. If you remember, we discussed that carbon forms 4 bonds, but here you saw that carbon was only forming 3 bonds. So 1 electron is left. This electron is free to move, and that's why graphite can conduct electricity. It becomes a good conductor of electricity. It's a soft textured solid, as the layers can slide from each other. The particles are packed tightly together, so it's very dense and has high melting and boiling points due to a lot of covalent bonds. And so due to the free electrons present in it, it can be used as electrodes required in electrolysis, which is another chapter. What are some uses of graphite? So it can be used in lead pencils. It can also be used as electrodes for electrolysis or in batteries, and it can be used as a dry lubricant. Now, why do you need dry lubricants? What is the problem with oil? There are some machine parts that can be damaged when you use oil or any liquid lubricant, so you require dry lubricants for that, and you can easily use graphite. Now let's come to diamond. So in diamond, you have a tetrahedral structure where each carbon atom is bonded to 4 other carbon atoms, as we discussed that each carbon requires 4 bonds, and so there are no free electrons over here. It's a 3-dimensional structure, and this structure has a regular definite geometry, and due to that it has a hard brittle surface because there is a network of strong and rigid covalent bonds. Now, what are the properties of diamond? So it's a giant covalent structure, and it's very hard. It has high melting points, and it is used in cutting tools because it's very, very hard, and it requires a lot of energy to break. If you put diamond in fire, nothing is going to happen to that diamond piece. However, it does not conduct electricity due to no free ions or electrons. And silica or silicon dioxide or sand has a very similar structure to diamond, due to which they have similar properties. Diamond is a brittle solid. It has high density, low solubility in water, and low conductivity. Now, what are the uses of diamond? Diamond tips are used in ornaments, and diamond pieces are used for drilling as they're very hard. Now let's come to sand or silicon dioxide. So it's a tetrahedral structure again. Every silicon atom is bonded to 4 oxygen molecules. But why do we say that its formula is SiO2? Shouldn't it be SiO4? No, because 2 silicon atoms bond with 4 oxygen atoms, and each silicon atom gets 4 bonds. If you look in this diagram, for 2 silicon atoms that all require 4 bonds each, you just require 4 oxygen. They can share all those oxygens together, as each oxygen requires 2 bonds, so each silicon can form 1 bond each with 1 oxygen. So for 2 silicon atoms, you require 4 oxygen atoms. That's why the empirical formula or the simplest formula is SiO2, and its physical properties are very similar to diamond. Now let's come to metallic bonding. What is a metallic bond? So in metals, what happens is that you have positive ions and their electrons. For example, you have aluminium that has cations of Al3 plus. 3 electrons from each atom are going to come out, or they will be delocalized, and a sea of delocalized electrons will be formed. Think of the sea as a glue. It's a sea of electrons, and these electrons hold all the positive ions together, because theoretically positive ions or cations should be repelling each other. But why are they very close to each other? Because you have electrons, negatively charged particles between them, that are holding them together. So what are the properties of metals? Let's discuss all of these properties. They're malleable. What does it malleable mean? It means that metals can be bent and shaped without breaking. How is your spoon shaped? It's because the metal is malleable and it didn't break while you were shaping that spoon or any other metallic item. Why? Because they consist of layers of ions that can slide over one another. So when the metal is bent, hammered or pressed, nothing happens. It doesn't break. The shape, it can change shape, the metal can change shape, but it won't break. When you applied pressure to ionic compounds, unlike charges came together and crystal cracks were formed. Whereas in metallic compounds, what happens? When you apply pressure, the ions can easily slide over each other. The electrons help with that. Think of them as a glue. The sea of delocalized electrons is a glue. They help the positive ions slide over each other. Then these metals are ductile. What does it mean? They can be drawn into wires, which makes them suitable for electrical cables. This again is due to the ions being able to slide over each other. Metals are good conductors of electricity and heat because the localized electrons can move throughout the metal, and movement of electrons is electrical conductance. Then they also have high melting and boiling points. The greater the number of outer electrons that the metal has, the higher its melting or boiling point. For example, aluminium has more outer electrons. It has 3 outer electrons, whereas sodium metal has only 1 outer electron. So aluminium has a higher melting or boiling point than sodium. This is due to the increased positive charge on the metal ion and the increased number of electrons that are delocalized, resulting in stronger bonding. Now let's have a look at some definitions. What is an atom? We discussed it's the simplest unit or the simplest particle. What is a covalent bond? A covalent bond is formed when atoms share electrons to achieve a full outer shell or a full valence shell. What is an electron? It's a subatomic particle. You won't say that I can break an atom down further to electrons. No, because electrons do not retain the property of that element. Now electrons are negatively charged and they do not have any mass that can be counted. Their mass is negligible, it can be ignored. What is an electrostatic force of attraction? It's a force of attraction between particles that are oppositely charged, for example cations and anions. What is an element? It's a substance that is made of only one type of atom. Molecule consists of 2 or more atoms that are chemically bonded. The nucleus is the central part of an atom that has protons and neutrons, and around it in electronic shells you have electrons. What is stability? Atoms are stable if their outer shell contains its maximum number of electrons. Thank you.